Good afternoon, everybody. Looks like most people are here, so let's get this started today. So my name is Megan Skilton. I'm your National Account Manager here at Wolseley, and today we will be covering the Ductless Service training. Same thing as every other presentation that we've gone through. If you have questions, feel free to use the chat. Seems to be the most common method, or you can just raise your hand. Keep your microphone on mute if you're not speaking. And Craig Anderson is going to lead us through our presentation today. He is our TSA in Ontario, our lead TSA. So I'll let him introduce himself and some of the changes that he has for his program here, and we'll kick this off.
Good afternoon, everybody. Thanks for coming out. So today we'll do some ductless training. It'll be about an hour long. I know it's not the most convenient and way we want to do training. At this point, we'd all like to be in a lab where we can touch and feel things, but for now, this is what we can offer you. So hopefully it's PowerPoint is not too mind-numbing for you and you get a little bit out of it. So as Megan says, my name is Craig Anderson. I work for Wolseley. I help lead up the TSA program, Technical Service Advisor program for Wolseley in Ontario. And I also assist the Atlantic Canada area for doing service as well. So changes to our program. If you knew about our program, we had one full-time TSA, which was myself, and then we had a lot of little TSAs over Ontario. I'm happy to announce, as of yesterday, we have now 3 full-time TSAs that will be answering the phone. Plus, we'll still have our part-time TSAs that are working at the branch. We're working on the force so we can take care of Ontario a little quicker for you guys when we're doing TSA calls. So you're going to call one of us. We're going to go through the problem with you. If we need to reach out to someone else, we'll do a 3-way call and we'll get it done. So we're working on making that as painless as possible for you. We're training our guys. We're doing everything we can. We do not know it all, but just talking to someone on another line or one of your partners seems to always help us get through what's happening out there. So hopefully your experience, if you had experience with us before, it was pretty good. We're going to be getting better at it. Like I said, we're hoping for 4. We have 3. We're hoping to teach the branch guys at that level a little bit more than what they know. A lot of feedback is your branches don't know a lot. They have a lot to know at the branches. And as us being technical service people, we have a lot to know. We have to know heat pumps, we have to know mini splits, air conditioners, boilers, all that stuff. So anything we can do to help you when you call, we'll do it within our power. So hopefully we'll be about an hour. Like I said, hopefully it's not too painful for you, but we'll get rolling here. So I always start off the presentations with this website, gokeepright.com. It is fantastic. Any of you guys doing service out there in the field should have this on your phone, your laptop, in the office so you can get to it. This is the site we go to for installation manuals, technical manuals, stuff like that. If you're going out to a job site, you know you're going to be doing a mini split. We all don't do a lot of service on mini splits. Go to gokeepright.com, pull up the technical manuals, print them if you have to, do some reading on what the customer told you that error code is so you know what you're going to go looking for. We all know when we open these boxes, it explodes. There's a lot of stuff going on in a little box. So when you go to that site and you click on it and you go to Keep Right, there's no password. You don't need nothing to get in it. So once you get onto that site, your little box is going to be this search box over in the right corner. First 4 or 5 digits of the model number will bring up what you need. If you put too many things in there, it's just not going to find anything, or you're just going to pull up every manual known to man. So first 4 to 5 digits, hit the search box. Owner manuals, technical manuals, warranty, all that stuff will come up where you can find these error codes, stuff like that. So great website. Make sure it's on your phone or your laptop, whatever, however you guys work. We all know when we get to a job site, chances are the manual is not there. If you need a bigger screen to look at, all customers have computers, most of them. Pull it up on theirs so you can read it properly and get to you. So ductless splits, there's 2 different ones. We have single zone and we have multi-zone. Single zone, 1 head, 1 outdoor unit. Multi-zone, we can do up to 5 indoor units, 1 outdoor unit. So you'll notice in this picture on our multi-zone, which is nice about our units, is we have master valves on the top, and then each unit has its own separate valves as well. So if you put a multi-zone unit in and you have an extra port for future, you can go back and add an extra head without pumping that unit down and doing all that stuff. You can add it on, do your vacuum, away you go, open your valves and get that other unit started. If you're having a problem with one of the indoor heads, you can isolate that valve and just take that head out of the equation. So nice little feature on our multi-zone. What you're going to see in the box is you're going to get an indoor unit, a controller, and the manual that's going to come with all the indoor unit, and then you have an outdoor unit, as we all know. So error codes. Error codes are going to tell us or give us an idea of where we're going to look. Each unit has different ways to read error codes: indoor unit, outdoor unit. So on our inverter boards, our 9, 12s, and 18, the boards are together. Your main board and your power board are all in one board. When you get to the bigger units, the 24s to the 36, the inverter board and the main board is separate. So things to look at, you're going to have 2 boards in the bigger units. The smaller units, you're only going to have 1 board located in it. And yes, some are going to be upside down, some are going to be upside right. And we'll go over that in some of the pictures as well. So when we're looking at sizes 9 to 12, 115 volt units. So be mindful when you're working on a smaller unit, a 9 and a 12. These units can come in 115 volts or 230 volts. So be mindful when you're checking your power or hooking up power to these units, what voltage you're working with. So on the 9s and 12s, 115,000, these have LED lights pointed on the board. So when you're looking at it, you're going to be like a furnace, you're going to be counting the flash codes. Look at the panel on the unit, it's going to tell us what those flash codes mean. Or if you have the manual, it's going to tell us in the manual what we're looking at. So these flash codes are giving us an idea where we need to look next for our servicing. 9 to 18,000s, the 208 volt, 230 volt units. We're looking at 3 LED lights. So each LED light will give you an idea of what's going on. One will be blinking, one will be solid on. So things to look at when we're looking at an outdoor unit. 24s and 36s. This is where you see we have 2 separate boards. We have a main board and we have an inverter board. You can see the separation in between the 2 boards. So we're going to be looking for our LEDs will be on each board. So each one will tell us different codes. So here gives you an idea of what some of the codes are. Normal standby, so you have a red LED or a green LED, it's going to be flashing or it's going to be on. So that gives us an idea of where we're going to look. So your outdoor unit is going to have codes, plus your indoor unit is going to tell us codes as well. So be mindful if you're looking at a code that's on the inside, it's not making sense. It could be the outdoor unit that's faulting and giving you a code. So make sure before you go to the job site that you're mindful of what unit you're going to work on and what kind of codes that we're going to be looking for when we get there. So when we get into the multi-zone units, they're a little bit different as well. We have 2 zones, 3 zones, 4 zones, plus we have 5 zones. So the smaller chassis, the 2 to 4 zones, you're going to be looking at an inverter board and a main board. When we get up into the big dog, now we're more zones, we're more stuff going on. We're going to have inverter boards and we're going to have main PCB boards separate as well. So that unit there is going to have 3 boards now. So just be mindful of that. If you're working on a big unit and you're not figuring out the problem, there might be another board in there that you need to look at. So I'll give you an idea on the multi-zone units. When we're looking at error codes, you'll notice this one board is flipped upside down, and then we have the other board flipped upside right. So this one here does not have LED flash codes. It's actually going to give you a code like E1 or E2, P3, codes like that. So that'll be on that little display that's on the board. Your 4-zone boards, when you open the unit, this is going to be similar to what it's going to be looking like. You're going to have a little sight glass there where you can read your error code as well. 5 zones, your boards are going to be upright. It's going to have a little display like that as well where we can read that code on the outdoor unit. So it's a nice thing. We have codes on outdoor, we have codes on indoor. We'll be able to decipher by our troubleshooting charts where we need to look and what the unit is doing. So here's our high wall unit that we'd be looking at. So in your high wall unit, that'd be where the location of your error code is going to be on the high wall unit. It'll light up for you so you can see it, or the customer can see it and give you an idea before you get there of what that code is. If you're getting into ducted units, there's a little display box inside the ducted unit. If they left it inside the ducted unit, you're going to have to take the cover off the unit to get to see this display unit. If the guys have installed it, that bar is on a wire, so they could actually physically mount that on the outside of the unit if they wanted to. If they do, then now we don't have to take the unit apart to go in to see what that error code is. But on the ducted unit, it'll be on a bar just like that picture there, and that will give us our error code. So 4-way ceiling cassettes, floor consoles, they do not give error codes. The infrared things that are on there are just the infrared signal for the remote controls. So they will not give you an error code. Your error codes will be on your remote control or your outdoor unit. So if you're trying to figure out it's not giving you an error code, it's not going to. You have to go to your remote or your outdoor unit. So system components, this is how the unit is going to operate. So there's a bunch of thermistors out there, return air sensor, evaporator sensor, coil sensor, outdoor temperature sensor, discharge temperature sensor. They all do a different function to help this unit turn on and turn off and modulate. So we have to be real mindful of these sensors and they are in the right location. If they have fallen off or something like that, that could give us sensor errors or erratic operation of the unit. So
there's a question from Dave in the chat. Is there any weather sealing protection on the control boards themselves?
On the outdoor units, the only weather protecting is the covers that are on the unit. There's no actual physical cover that's sitting on the unit. So when you take that cover off, then you'll be access to the board.
Thanks, Craig.
So system components of how this unit is going to operate. Our first one is our return air thermistor. So this is the sensor that is reading the air that's coming back to this unit. So installation is a big thing. Your clearances, if it's too high to a ceiling, we're bringing a lot of hot air up there. So we need to make sure that the unit can breathe on top, that we're getting the proper airflow to it. Locations of walls adjacent to the unit. Some people put these in mechanical rooms, or they put them in server rooms, where the server room is only 6 feet wide and we're putting a 2.5 ton unit on that wall. The unit is blowing, it's hitting the wall, and it's pretty much just recirculating in there. So what's happening is our compressor is working more than it needs to, turning on, turning off, stuff like that. So airflow is another big thing that's going to affect that thermistor itself. So location is a big thing on that. So that is mounted on the inside of the coil. Once you take the cover off, just make sure it's in place and it's reading everything properly. It just plugs into the board and goes right to that coil. Evaporator thermistor, it plugs into the board as well beside the other one. You can't mix match them. They're different, so we can't plug one into the other. Evaporator thermistor is a proving sensor. So once the unit turns on, our compressor turns on outside, this is reading, hey, I've got refrigerant going through it. This is the temperature of my pipe. This is what I'm going to tell the EE valve to do outside, because we're a modulating unit. So it's going to work with the EE valve to modulate the amount of freon that's going through the unit. If it's not reading properly, if we're undercharged or overcharged, then it's going to determine how the unit is going to operate. So all that is a prover switch to tell us gas is going through the unit and how much. So when we're dealing with multi-zone units, evaporating, leaving temperature, because we have multi-zones, each zone is going to have a sensor as well. So they can all modulate between each other and how they're going to operate. So be mindful of when we're looking at, we're opening up a unit, that the sensors are in the proper location, they're still attached. Very rarely that they come off, but we've seen it happen. They're on there pretty good. It takes a lot for them to come off. Outdoor air thermistor. All that is doing is reading your outdoor air temperature. It helps if the unit is in a heating mode and it's 87 degrees outside. We do not want that unit to go into a heating mode. It is going to stop that unit from going into a heating mode. That's all that temperature sensor is doing. It's telling us if it's minus 17 outside or it's 87 degrees outside. So be mindful of how they've located it. If it's too close to a wall, we're not getting proper airflow through there. It's heating up in there. Clearances mean a lot with these units because we're dealing with so many parameters with air sensors and temperature sensors. Condenser coil temperature. That's another one. It's in behind the compressor. It's on the condensing coil. All this sensor is doing is telling the unit to go into a defrost, or it's time to get out of a defrost. That is all it's doing. As long as it's on that pipe and secure, then we're good to go. Discharge temperature sensor. So this one here works along with your low pressure switch. Because these units, when they turn on, they turn on so low and then they ramp themselves up. So our low pressure switch is set so low because the smooth operation of the compressor and how low it is starting. So this discharge sensor is helping the low pressure switch out. So it's a loss of gas sensor. Let's put it that way. If there's no gas in the unit and the unit starts, the sensor is going to activate before the low pressure sensor. So it's just a backup, they work together. So this is what we're talking about with the low pressure sensor. So when we're dealing with the old compressors were on, the old compressors were off, hard start, off, hard off. These units here, because they're modulating, they start off at such a low hertz and then they work themselves up. So chances are of a compressor failure because starting and stopping is very slim. Compressor failure comes down to moisture in the system, incorrect charge, overheating because of a fan, power voltage going to a unit is most of the common compressor failures. Starting and stopping is not one of the big problems with a compressor failure on a mini split. And we don't see a lot of warranty compressors out there on mini splits. It does happen, but it's not as frequent as a standard air conditioner when we're on and we're off. So give you an idea how this works. So we're dealing with AC voltage, we're dealing with DC voltage. So when the power comes into the unit, we're DC or AC voltage, we want to be mindful of what's coming into the unit, that it's not too high or not too low. These units have a setting inside. Anything under 187, that unit will not start. Anything up over 153 or 253, the unit will not operate. It's powered too much. This unit will shut down. So if you're getting erratic, some days it works and some days it's not, monitor the electrical power that's going to the unit. If you're getting there, put your amp probe on it, let the unit run, let's see what the voltage is doing. Don't just check the voltage and take it off. Let's see what it's doing while the unit is running. So once we get into the unit, we're going from AC to DC. So DC is a very low voltage. It can't be dirty. It needs to be clean. It needs to have certain waves going through the system. So the unit needs to clean the power before it gets into the unit. So it goes through a whole bunch of different rectifiers and circuits to clean the unit. And then once it cleans the power, then we're going into our inverter board. And then we're going out to our fan motor, if it's a DC fan motor, our compressor, which is going to be DC as well. So how the power works, you're going into your, if it's a 2-board, you're going into your main board, then it's cleaning it and it's going into your inverter board before it goes out to any of the components. So typical principles of it, electrical power is coming in, is going through the rectifier. We're cleaning it a little bit. We're going through a reactor, which we're cleaning it a little bit more. Once we're going through the reactor, we're storing that power into the big capacitors that are in that unit. And then we're going to our board, which is going to our compressor and then going to our fan motors. Just a little idea of how it works. Clean the power, send it to the proper controls, and then we can send it to our compressors. So another picture, AC voltage is coming in. We're smoothing it all out and we're sending it to the transistors, and then we're going to the compressor. So we'll notice how the ripples have changed. We're getting big ripples, and then we're smoothing the curve to the DC voltage to make it a little bit cleaner, because AC voltage is usually dirty, especially if we're working in commercial properties or old farmhouses where we have a lot of poles going to the house. The electrical company boosts up the power at the end of the road so we have enough power when it gets to the house. So be mindful if we're having a lot of, say, boards or fan motors in equipment that has inverter power, you might want to look into putting a surge protector on it to help clean the power a little bit more before it goes to the unit, so we're not getting power spikes. We get it in commercial a lot. So if you're doing any commercial jobs, a lot of things going on, you might want to throw a surge protector on there for $130 and eliminate some more power problems down the road. So give you an idea of, you're going to see a board that's flipped upside down in the unit once you take the cover off and you get to that, that board that's upside down. Be mindful, if the power is onto that unit, there's power on the back of that board. There is actually testing ports on the back of that board where you can test power going to your compressor and your fan motor. So be mindful if you take that cover off, don't rest your hand on there. You could get a little jolt. Everything will be labeled, your W, your V, your U that go to your compressor, your P and N. So you can do some testing on the back of the board if required. So here's a cassette, and this is all in the manuals. So they try to put as much information they can in the manual, because when you're looking at this board, there's 12 things plugged into it. All the sensors are plugged into it, so that they've labeled them CN13, CN5. So that'll give us an idea of what location and what each one is doing. So in the manual, it's going to tell you too on your CN40, that should be 12 volts going to that piece of equipment, whether it's your sensor, reversing valve, or whatever it is hooked up to give you an idea of what kind of power you should be testing. So always look for those CN numbers on your wiring diagram of your unit to do your future testing. If there's a wiring diagram on the unit, always refer to the wiring diagram on the unit. Some manuals will have multiple wiring diagrams because there's different versions, different boards. The wiring diagram that is with the unit should have what is in that unit exactly. So you'll see reactors in the system on some of the main systems. So this is cleaning the power before it goes into the DC circuit. If a reactor has failed, we could get a communication fault because the voltage isn't going through it. So it's going to tell the unit, well, I can't talk because something has happened. So the reactors look like a little coil. There's usually a couple blue wires hooked up to them. Some of the units have the reactors built into the board. So some units have them, some units don't. So if you're looking at a wiring diagram, it will let you know if you have a reactor, and it'll tell you, and it's usually 2 blue wires that are going to it. So to check the reactor, we're just checking anything we deal with DC voltage. We're usually checking resistance on the windings, whether it's a compressor or a motor, similar to our reactor here. We're checking the resistance between the winding. So on this one here, a reactor, what does it do? It's cleaning our power going to the next step. How do we check it? We're going to check it for resistance. On a reactor, we're usually about a little under 1 ohms. If we're any higher or you're 0, then we're looking at some issues. We're not looking for an OL, that would be an open load short. We're not looking for that. And then no resistance to ground. So we're just checking the resistance to that. It should be in around 1 ohms. Compressor as well. We're checking resistance between all the circuits. So most DC compressors, this is how we're going to check them. Similar to DC motors, stuff like that. We're checking the resistance between the windings. And when we're checking them, all should be pretty much equal. So when we're checking the resistance on the winding, we're checking it from 1 to 2, we're checking it from 2 to 3, and then we're checking it from 1 to 3. So they all should be close. If one's like 1.6 and the other one's 0.8, then we're looking for some issues. Plus or minus 5%. standard in the industry when we're checking resistance and stuff. So just make sure it's not well out of the equation when you're testing it. I suggest testing it from the plug that you pull out of the board. Then I suggest you check it right on the compressor too. This is going to eliminate any problem that might have occurred within that wire. We've seen it before when somebody unplugs the plug from the board. They've grabbed the wires, they yanked it out, they put it back into the board, and they've yanked some of the wires out. And when they're pushing it back into the board, it's actually pushing the wire out a little bit more as well. So if you're pushing a plug back into the board, always grab the wires after and push the wires in as well, just in case one of those wires slipped out. It's happened many of times. We changed the motor. Guy puts it in, the brand new motor is not working. The wire pulled out. Once we pushed it back in, everything ran 100%. So always test at a board and always test at whatever you're testing and make sure the wires are pushed in. So the other one, checking for a short, ground to each terminal, make sure we're OL on your board. We're just checking for a ground. So what's the compressor do? Changes the speed to meet the capacity inside the building. So this compressor is ramping up and down. Any of these units, when we're working on them and we're going to test them, we're dealing with 3-phase DC voltage in a lot of the units. Make sure they power off and let those capacitors inside drain out. We could get an electrical shock. So we're going to check the resistance across the windings, and we're going to check the windings to ground. So we're going to make sure they're all equal under ground 2, and we're going to look for OL to ground. So when we're talking about the compressor and the compressor's modulating, when you're doing service and you're going back and somebody else has done work to this unit and he's told you, I put some gas in it, I took some gas out. Save yourselves all the headaches, get the gas totally out of the unit and weigh it in. Adding gas and taking gas out when a modulating compressor is working is not telling you anything. You have no idea what stage that compressor is in to check what kind of pressures you have. Only way to check pressures on a unit is you need to know that compressor is 100% in full capacity at that point. If it's not, your pressures are not going to be correct. So anytime you talk to a service guy on the phone or anything like that, you had a leak, I add a little bit of gas in it. No, take it out, make sure the leak is fixed, and weigh it in. If we weigh the gas in, we've taken that out of the equation. Doesn't matter if it's a standard air conditioner or a modulating air conditioner. Weigh your gas in. That is out of the equation when that is done. I know it's a pain in the ass, but it needs to be done, especially when we're dealing with a modulating compressor. EE valve. So this is monitoring the gas that's flowing through the unit. So our compressor is modulating. This valve is opening and closing to tell your sensor that's inside how much gas I'm going to put through this unit. Because we have a unit that's inside that can modulate from 3,000 BTUs to 9,000 BTUs. So this EE valve can move around 480 times. Whether it's opening or closing. So that's why we can't check pressures on these units, because we do not know what the compressor is doing or this EE valve. So always weigh it in. EE valve has a little twist on coil. It's got 6 wires going to it, and we'll go through that one next. So if you have a single zone, you're going to have one plug that's going to go into the board on your wires. If you have a multi-zone, then you're going to have an A, B, C, or D on there where it's going to plug in for whatever zone that it's working. Nice thing about this, if you have a valve that you think may be defective, all the coils on these things are exactly the same. They're just different coatings or color coatings or labels on them. So if you have a 5-zone unit that you're only using 4, you're going to have an extra coil on an EE valve. So if you think that coil is defective, you can actually take it off the 5th port, put it on the one that you think may be defective, and test it that way as well. So here's what we're going to be looking at on your plug. Like I said, it's going to be 6 wires coming out of that EE valve. You'll notice here on number 5, you'll notice that, as I stated, if you're pulling the wires, that number 5 has been pulled out a little bit. So now when they're going to plug that back in, chances are that's going to push out a little bit farther. So always be mindful of your plugs before you plug them back in. 5 and 6 is your common. Blue, orange, yellow, and white are our power going to our EE valve. So this is the kind of looks like what your EE valve does. It monitors the refrigeration flow that's going into your indoor unit. So it goes in increments or steps, as some of the guys say it. And it could have up to 480 steps. So this valve is opening and closing on what that return air temperature is telling it, the coil temperature sensor, what this compressor and outdoor unit need to do. So we get mindful that these sensors are in the proper location. They're not hanging off the pipe. They need to be in the proper place for everything to operate. Internal components, this is if you opened up an EE valve, that's all it looks like inside. I've been told by the tech department at ICP, EE valves very rarely fail. From what I'm told, they've seen maybe 2 within a year that they've seen fail. Failure comes to internal, your freon that's going in it, because you're inside your EE valve, there's little screens that if they get blocked or anything like that, if something has been added to the system, like dye, or somebody put Loctite on the nuts outside and it got in the system, this is where we're seeing failure of EE valves or TX valves or reversing valves, is stuff has got into the system. There are little things that you can buy. It's a little magnet online. We do not sell them at Wolseley. I'm told you can buy them on eBay. It's a little magnet that slides over the valve, and you can actually hear the magnet working to see if the EE valve is opening and closing. But that's what it would look like with the coil off it, and the coil just slips over top of it. Just a magnet that's opening and closing it. So how do we check it? And what it does, as I said, it meters the refrigerant to the indoor unit. We ohm this out as well, between our red and blue, red and yellow, brown and orange, brown and white, same thing. We're looking at for resistance that's equal. So when we're dealing with DC voltage and windings and stuff like that, we're always looking for a voltage that is equal to each other or just off a little bit. The other thing that you're going to run into, and I think most of the sales now, are units that have heat pumps with reversing valves put into them. So on our outdoor unit, our reversing valve is energized in heating mode, not cooling mode. Where a lot of the units, reversing valves are energized in cooling. So if you're checking the heating system and you need to check the reversing valve, then when you're testing it, you're looking for the voltage when it's going into heating and no voltage when we switch it back over to cooling. To check the reversing valve to see if it's operating, you could put a little magnet on the side of the reversing valve and energize it. Then you would see that magnet slide back to where the copper is in the reversing valve. YouTube is the greatest thing out there for a service guy. Get on there, Google things. It shows you how to do it, how to put a magnet on it to see if the reversing valve is opening or if it's sticking. You could think it's opening all the way, but it's not. Putting a little magnet on the side of it and getting it to energize, you'll actually see that magnet slide. It's pretty neat and simple to do, to check to see if it's moving or not. But reversing valves, 220 volt reversing valve on it, energized and heating. So what the reversing valve does, it's just changing the flow from cooling to heating. It's switching over also when we're going into a defrost. It's going to switch the unit into cooling to melt the stuff off outside and go back after that is done. You can ohm out the coil on the reversing valve as well to see if the ohms are good on it, or we check the voltage from the board to the reversing valve to see if we have 220 volts in heating mode. Fan motor, similar to compressor, all that. We can check the resistance to it. We can check the pulsing voltage going to the motor 2 on the board on our CN414. We're checking the motor circuit. We're looking for a pulsing DC voltage to that fan motor to make it turn. As I said, it's all in the manual, and it's going to tell you what CN14 is doing, or it's going to tell you in the wiring diagram on the unit. So motor resistance, same as our compressors. We're checking them all, blue to yellow, blue to red, yellow to red. Same as everything else. We're looking at a resistance that's in the same parameters, nothing that's way out of scope when we're checking that as well. So what the outdoor fan does, it takes the heat out of the unit and blows it out. We can ohm out the motor windings, or we can check the DC voltage on the P and N tabs going to that fan motor to see if we have that pulsing voltage going to it. So operation modes for our single zone and multi-zone. It's just a couple diagrams how you're looking at an indoor unit and outdoor unit. So we're looking at a single zone. Our coil is not, it's de-energized. It's not being energized, so we're in cooling mode. How the gas is flowing to the indoor unit to the outdoor unit. Just a simple picture of how your gases are going to be flowing. And then you notice in the heating mode, now our reversing valve is energized. So our flow of gas have changed. Now we're into our heating mode. That's all that is doing, is changing the flow of gas. Now, once we get into a multi-zone, similar, the way the gas is going to flow, the four-way valve is in cooling, so it's not energized. And then you'll notice all the EE valves. So each circuit has its own valve that's going to monitor what that indoor unit is doing. And then when we go into heating mode, everything is going to change. It's going to switch around. System inquiry. So this is going to tell us what we can try to look at to see if we got some nuisance stuff going on. We can get into the background of the unit to test some things. So on your main control, we're going to press the LED 3 times. We're going to press the swing 3 times. You're going to hear the unit buzz, and it's going to get us into the remote control function to test some things and look at some things of what the unit's doing. So we can do this while the unit is running or when the unit is off. So what we can do is while the unit is running, we can actually see what the return air temperature is going to that unit. What's your evaporator coil temperature, your outdoor coil temperature, outdoor air temperature. So give you some ideas if something weird is going on, if the outdoor air temperature sensor is not working, we have a pocket thermometer out there. It says it's 40 degrees, and if we look at the remote, that sensor is saying it's 80 degrees. So hey, we know something is going on. It's getting extra heat from somewhere. So this is just a little background what you can do when looking at a unit and seeing what it's doing. It's all in the manual for the remote where it would tell you to get into the system inquiries. And really only if you're having real big problems out there with stuff like that you're going to go in and do this. But it's a great thing to do if you have one in your shop or a buddy has one, or if you're at a customer's house and you got some time, go in, play with it, see what it's doing. This is how it's the only way we learn is to actually touch and feel things and get into to do it. So if you have that opportunity to stay back on a job site or at your shop, just go out there and start testing things when things are working. So you have that opportunity to say on the next one, this is what I had at the shop, this is what I should be doing. So system inquiry can be done on the outdoor unit as well. On some of the boards, it'll have a little SW1 switch, and then you'll have your little display up there that what's going to tell you what you're in. So that one's done a little bit differently. It's the number of presses. So if you press that button twice, it's going to tell you the outdoor mode. It's going to tell you a frequency. So it all depends on how many times you press that button and what your display is going to read. So when you first open it and it's working, you're going to see it's going to tell you the frequency of the compressor. So it's going to give you an idea of what range the compressor's in, if it's in half mode or full mode, running state, and that display is going to give you error codes as well. So we can get up to a number of presses. You're going to have to press that little button 33 times to get the outdoor air temperature. It is what it is. If that's what needs to be done on a job site, then we press it 33 times to make sure that sensor is working properly. So a couple pictures. We always like to throw some pictures in guys have taken on job sites. Somebody tried to do zoning with this unit, built a wall and shoved it in between. Good luck servicing it. This one here, we definitely have some problems. It's probably freezing and they had to put an extra drain pan under it to compensate for dripping water or freezing. You'll notice it's quite tight to the T-bar ceiling, so airflow was probably one of the biggest issues on that one. This one here with the bag, we're not 100% sure what they were trying to accomplish on that one. This is another big thing, guys, too. If you're going on calls that have multiple units outside or beside the house or on the roof, it's nice to put them all in a line. They have clearances. Look at the clearances in the book. If we start with one unit, this unit's blowing into this one's blowing into this one. So once we're getting in the center and we're getting on the far one, somebody's overheating at some point. So we're going to get erratic behavior on the sensors and the operation. It could overheat the compressor. It could overheat the fans. The other picture here, this is, I don't even know how any of them work. If you really look close and look at the back, there's more that are back there. So whoever installed those should all be shot. I can't even see them working. Here's a big one as well when you guys are out there doing, if you're getting communication issues, look at your environment. If it's computer rooms, stuff like that, what kind of wire they use. We want 14-3 stranded wire. This is a communicating cable. It's like computers, it's like speaker wire. We want it. We get better communication through a braided wire. So make sure they've run the proper wire. This one here, it looks like they've used a low voltage wire, and we're not sure what they've used on the signal wire here itself. So be very mindful of the wire that the person has used if we're getting error codes and stuff like that. Make sure our wires from indoor to outdoor are the same, L1, L2 to S. They need to match outdoor to indoor. We cannot mix up L2 and L1. L2 is actually a signal wire as well. So make sure that is wired properly. This is a ducted unit. The manual is out, but I think the manual came out after the fact because they had an issue with it. If you're not for sure of what you're installing, open the manual. This one here, there was 11 units. These ducted units have brackets on them to put threaded rod through to hang it from a ceiling. They thought the brackets were to screw it to the ground. They installed all these units upside down, all 11 of them. They turned all 11 on. They all coded out because the float switch inside was upside down. So be mindful. Open the manual if you're not 100% sure, just to see what you're installing. They had to go back and reclaim all of them, flip the units upright, and get them up and going. I think we got a couple mock-up pictures here. There's no way somebody would install a ceiling cassette upside down in a ceiling like that. It's almost impossible. I don't think anybody's that bad. This is another big one. If you're working on a unit and they got Loctite on the outdoor unit, they did not flare it right. They did not torque it down right. We don't want Loctite on our units. If the unit comes back and has Loctite on it, you will not get warranty on it. You'll notice the Loctite is inside the pipes. Once inside the pipes, it's going to get into the strainers. It's going to block your EE valve. It's going to do damage to the indoor unit. We're dealing with 1/4 inch line. We're dealing with 1/2 inch line. Anything that's obstructing flow, kinks, blockages, anything like that is going to disrupt your flow to your indoor and outdoor unit. So mindful of kinks, Loctite, anything like that. This one here, they did put tracking on it. That's fantastic. They wanted to cover up their pipes. The thing they did not do is they did not seal the hole going from the outdoor to the indoor unit. So they're getting gushes of cold air or hot air. And where is that going? It's going right into the back of the unit on the sensors. It's affecting the sensors. It's making erratic operation, overheating, undercooling, anything like that. So check the holes where the pipes go through to the back of the unit as well. This one here is half up in the T-bar ceiling and halfway down. We're not getting proper airflow to that unit. It's not going to run properly. This one here, nice clean install, looks fantastic. They have it tight to the ceiling. That's where your return air is being drawn in. We're restricting the return air. This one is hilarious. They must have done some work on the side of the building and they had to move this. There's no way somebody would install it like that, but it is quite funny. So this is a flare. Like we were talking about the Loctite. If you flare it properly and you torque it properly, you're not going to have a leak. You're going to get brass on brass and it's going to seal. Going to get a bigger wrench isn't solving the problem. You're going to mushroom it. You're going to make the problem worse. We do not need a lot of pressure to make these things seal. So error codes, troubleshooting. With troubleshooting, we're looking for the problem. We're trying to get to the bottom of the problem to solve what the error code is, determining what the cause is, and trying to eliminate it, whether it was installation or if it was actually failure of the unit. In your manuals, you're going to get flowcharts. Flowcharts are flowcharts. They're going to bring you to the area where you should be looking. It's not going to fix the problem. It's just going to get you close. It's like an error code on a furnace. Pressure switch. We know the pressure switch failed. Now you have to figure out why. Error codes and operation codes. So there's two on the unit. You're going to get an error code if something is going wrong. Your unit is also going to have operation codes. So when they turn on their unit or turn off their unit, it's going to flash a little code like CF, or you're going to get a DF if the unit is in a defrost. The unit is actually going to give a code. 2 lines is mixture mode. If you have a multi-zone unit and they try to put heating on one and cooling on the other, it's going to give you 2 lines. They can't operate like that. So you have to figure out what's an operation code and what's an error code. So if a customer calls you and I got DF coming up all the time, but the unit's running, stuff like that. So read the manual, see what the operation codes and the error codes mean. E1's our biggest one. Error code, outdoor, indoor unit are not communicating. Wire, like I said, 14 3-stranded wire, indoor to outdoor unit. You don't want morettes, you don't want junction boxes. L1, L2, S, make sure it's the same indoor, outdoor unit. Component failure, indoor board, outdoor board, stuff like that for E1, but that E1's a communication code. So like I said, make sure there's no wire connectors between the wires. We want a solid wire from indoor to outdoor unit. So just your wiring, like I said, it's a signal wire. So L2 and S are your signals, and then L1 and L2 is your power. So you got to be mindful that L2 is a signal wire as well. If you have an electrician going out there to wire, they don't differentiate L1 and L2. So be mindful before you flick a switch that he has them correctly, or we're going into an E1 code. So just an idea of what the wire looked like. 14 3-stranded wire is what we want. You want BX cable. There's special wire for ductless splits. We sell it at all the branches. Buy the right stuff. Let's eliminate anything else that can go wrong. If we get the installers to install it right to how it works properly, then the servicing is much easier for everybody. So indoor and outdoor unit wiring, we have a single zone and then we have a 5-zone. So like I said, L1, L2, and S need to go to L1, L2, and S. L2 and S are your signal wires, and then L1, L2 are power wires. So L2 is a signal wire as well. 5-zone units or 2-zone, 3-zone, make sure zone A is wired with zone A, B with B, C to C. If we get the wiring mixed up, then you'll get erratic behavior of the indoor unit. We could have one indoor unit running and the fan coming on, but we have Freon going through unit C because we have the wiring mixed up. So you'll have one unit freezing and then one unit sort of running. So if you're getting a call with weird stuff like that going on, always go back to the wiring to make sure that it adds up to the indoor and outdoor unit. Get that probably about 6 times a year. They mixed up the wiring. It's doing erratic things. Another communication failure, a wiring issue. They went in, they mixed up the wires from the indoor to the outdoor unit. They had L1 on S. As soon as they powered that up, they put 120 volts to S and they fried something. So wires need to match up, very critical. So like I said, L1, L2, and S. L1, L2 is power coming in when we're checking our 220 volts. If we're checking our communication between our indoor unit, we're checking it between L2 and S. This is our signal. This is where we want to see outdoor unit is talking to indoor unit. So typical operation, you're going to see your DC voltmeter go from a minus 30 and it's going to go up to plus 50. It's going to go minus to positive, minus to positive. If you're testing it and it's staying in the positive, that's telling us we have something going on with our outdoor board. If your voltage reading is staying in the negative when it's doing it, that's telling us that we have a problem with something's going on with the indoor board. But if we're getting a positive to a negative, that's telling us we're getting some communication, something else is going on. So different codes, P4, P6. Every unit's going to be a little bit different with a P4 and P6 means. We're looking at compressor discharge temperature protection. So we're looking at refrigerant charge, refrigerant flow through the EE valve, exceeded line lengths, compressor, bad board, stuff like that. Give you an idea where you need to go to look of what the problem is. P6 checklist. Does it do it in heating and does it do it in cooling? Does it come on right away or does it take 10 minutes before the unit turns on? So does the unit turn on and then we're getting a P6 after 5 minutes or something? That would sort of go towards a refrigerant problem sort of thing. Multi-zone units, their wiring going correctly. Crankcase heater would overheat a compressor if it's staying energized. Outdoor air temperature too high, overheating our compressor because they got the fan motor pushed right against the wall. Other things to check for mechanical checks, like I told you at the start, our units have master valves and then each zone has its own valve. They all need to be open. I've been to job sites. I drove 3 hours and got there and they didn't open the little valves all the way. They opened the main valves, but they didn't open the other 2 valves all the way. They just cracked them. So they were getting poor refrigeration flow to the units. So make sure they are all totally open. Verify your EE valve, your everything's energizing and de-energizing on your reversing valve and heating or cooling. Electrical checks, ohm out your compressor, your reactor, check your DC voltage, ohms to your fan, your compressor, your stepper motor, all things that are easily done from the outside. We can ohm things out to make sure we can eliminate that from the get-go. So here, no refrigerant flow. If you ever had to weld any of these lines, if you're running over 50 feet and you're welding them together, make sure we're putting nitrogen through the line. You're getting enough heat. We're not blotching up the freon or the line when we're doing the welding. Like I said, master ports, make sure they're fully open, and then each of your individual ports are open. So if you have a 2-zone system, you're opening 6 ports on that baby. Make sure they're all open. And so error code P4, P6, inverter compressor drive error, IPM module protection, bunch of things, communication between main and inverter board, high voltage, low imbalance, that's your power going in, is it fluctuating back and forth? Easy things that we can check before we go and check. We could have just a power fluctuation that's screwing everything up. Make sure your power coming into the system is constant, it's steady, it's not fluctuating around. Compressor, reactor, stuff like that, that's stuff that we can do a resistance check and to get that all checked out. So here's a EE float error. Like I was telling you on that ducted unit, they were all upside down. It went right into an EE code, all of them, because the float was upside down. So on those ducted units, there's an access hole to get in there and look at that float to see if it's stuck, if it's overflowed or anything like that. So E valve, it's not draining, the line's pinched. As we stated on install, get away from using plastic tubing. Let's use PVC. It doesn't kink, it doesn't sag, as long as we're putting it in properly. Clear tubing is going to sag, it's going to cause extra P-traps, stuff like that. So check that stuff out on installation as well. Large temperature swings, we talked about that. Controller location is one of them. It's not in the right spot, and they're moving it around, and it's getting erratic behavior. Your hole is not sealed outside, and we're getting airflow that's going into our sensors. It's oversized. It's bouncing against a wall. It's too tight to a ceiling. That'll give us large temperature swings in a house. So we have to look at turn down of these units too. If we have a 12,000 BTU, it can only turn down so low if they only have it in a little room and they threw a 12,000 in there. So large temperature swings could be the unit is oversized. It's giving you a rush of heating, and by the time it turns off, the room is overheated. So need to look at that as well, the size of the unit for the size of the room. So you'll notice on our units, turn down ratios on an 18 is 58, and it'll actually heat or cool up to 21,940. So an 18,000 is actually 22,000 BTU unit. So things to look at. Did they need a 24 or anything like that? 18 might have been big enough because it can actually cool to what it needs or heat what it needs. It'll heat to 24,000 BTUs. So did you need to go to a 24? Your turn down ratio on an 18 is less than your 24. So things to look at for large temperature swings. When you're into multi-zone units as well, if they're actually a multi-zone unit is designed to be a multi-zone unit, they're designed to all be on, leave them on. It helps out with the refrigeration flow to each unit. It'll allow Freon, the excess Freon, to go through the other head while the other head is not actually running. So it'll help your operation of your other unit, keep them all running. So you'll notice your minimum BTUs on that now, if you have both of them running, is 3,500. So we might not get a large temperature swing when the minimum, if the other one's off, is 58 now, depending on your room. So things to look at. Service on your remote control, we went over it a little bit before. So we have a service menu, hold power and swing down, and then we can get into the F1 screen change. Like I said, this all on Go Keep Right. I know you aren't going to remember it all. It's great to go on there and see what these service things are. So in the service remote one, we can go in and change parameters of the system on how the system is running, similar to a Honeywell thermostat on the wall, but we're doing it from our remote. So we can turn the auto restart function on or off. If the person loses power, this unit will go back and start automatically. You can turn that off. Anti-cold blow. So the unit's going to heat up before the fan turns on. We can turn that on. We can turn that off. If you have a heat pump unit and they only want cooling, you can turn the mode off. You can turn the heat pump mode off, or you can turn the cooling mode off and just have heat pump if that's a function they want. So that's what we can do in the background of your thermostat or your remote control as well, like your parameters on a standard Honeywell stat. Highest set points for cooling, lowest set points, stuff like that, also that we can change on those parameters. So this is similar to what we were looking at before, getting into the background, pressing it 3 times, your do not disturb, and your swing 3 times. Your indoor unit's going to beep. And then we can get into the next step. So your LED now is going to bring us your next information. Your swing is going to be your previous, so we can go back and forth in that remote if you really need to get in deep to that. So like we were saying, and you're going to get your display codes, whether it's T1, T2. We can check our outdoor temperature, stuff like that, right by your remote control while you're sitting in front of the unit and the unit is operating. You don't have to run outside to see what the temperature is, stuff like that. You can see it right from your remote. You can check indoor fan speed. You can check the frequency of what the compressor is doing outside to give you an idea of what stage it's in. And your E valve, is it open 100% or is it open 80%? So great things you can do by the remote control, but you need to sit and play with it in front of a unit. And then once you're in there, parameter checking operations, it's going to be in your manual as well. It's going to tell you how to read the settings that you're getting. So you're going to get a reading. So in your indoor fan, it's going to say 1, 2, 3, or 4. That's going to tell us what speed we're in. Stuff like that in your manual. But this is information you can get in the background if need be. So here's some your codes that are going to show up if we're in the background. Each number is going to tell us if the unit's defrosting or the mode is switching, what your AC power is, stuff like that. So I said we can get in deep if we have to, if there's something funky going on with that unit. And that's what I have today for everybody.
Thanks so much, Craig. Is there any questions for Craig today at this point? Craig?
Oh, hello.
Can you hear me?
I can hear you now.
Sorry, my computer is at max storage and it keeps kicking me out of my stuff. There is a question in the chat. Is there a maximum line set length for these units that's required?
So each unit, whether it's a 9,000, 12, 18, every one of them have different line lengths. So you'd have to look at each particular one. So some will say 70 feet, some will be up to 90. When we get into multi-zone units, it'll tell you you're allowed 200 feet of piping. So you can split that 200 feet of piping between the two units. So we always want a minimum of 10 feet, doesn't matter what it is per zone, but that zone could be 35 feet and then you have the rest of that to run to the next one. The only problem is when you get into real long line lengths like 50 feet and over, just because it's a 9,000 BTU, when you're running a real long line length, you're losing capacity on real line lengths. But each unit has its own length. Multi-zones are nice because we can split it up between the 3 zones or the 2 zones.
Okay, hopefully that helps answer the question. Are there any other questions for Craig? All right, so we'll close off this meeting. If there is anything else, feel free to reach out. Thank you for your participation today and sorry for going a little bit over. Next week we have 2 more sessions. So we have the cooling and then we have the EPMS service bench program support, review. So hoping to see you guys on those sessions, and have a great rest of your day.
Thanks, everybody.
Bye-bye.